Hello everyone, my name is Mayur and I'm in 8th grade. Something about me is that I really love to do math. It's not just because it's my work or I have to do it or it's homework or something from school or my teacher gave it to me or nothing like that. I do it for fun. And why is that? Because I find math really interesting and the concepts are so intriguing I just can't stop solving problems. However, I am aware that a lot of people do not like math. So I thought, for those of you who don't like it, I can share with you a slightly different way of viewing and solving things in the hope that you'll eventually start to like it. Alright, without further ado, let's get started. Today's topic is about quadratic equations, or just quadratics in general. I'm sure a lot of you have at least heard the term quadratic equations, and if that confuses you, don't worry about it for now. Quadratics are basically the graph, a graph with a graph that produces a parabola. For a parabola is what looks like this in the coordinate plane. So if you were to graph it on a pair of axes, then you'd get a U shape sort of like this when you graph a parabola. And that's basically the graph of it. And the equation, the general form is y equals ax squared plus bx plus c. So yeah. Now, why should you know quadratics? Why is it so important? Well, let me show you this. If you're interested in, for example, the military and law enforcement field, then take a look at this. This ballistic missile is being launched at its target, and you can see the outline of a neat U shape there. And guess what that is? If you guessed a parabola, you're absolutely right. This is, in fact, the representation of a parabola in real life. So quadratics are used heavily in the military field and defense systems of any missile and things like that. Also, if you're interested in sports, here's a basketball going into a hoop. Again, look at that outline of the U shape that it takes to go into the hoop. Again, it's the graph of a parabola. So there's another way you can see quadratics in real life. And if you're interested in architecture, then take a look at this. I'm sure you've all seen this picture before. It's the Colosseum, and it's one of the seven wonders of the world. Now, those various U shapes all over it, what do you think they are? Well, of course, they're arches, but what do they represent? That's right, it's a parabola again. So, this just shows you how much quadratics are used in real life in things right in front of you and you wouldn't even realize it. Imagine how much more applications you could do in fields other than this in so many different ways. That just proves how important quadratic equations are, not just in math. Okay, so let's actually get started now. We're going to work on trying to find the graph of an equation, and that equation is going to be x squared, y equals x squared plus x minus 6. There are two ways to find the graph of this equation. Now I'm going to show you the first way, and that is to make an xy table. Let me draw out that table to show you what it really is. It's basically two columns, with the left one being x and the right one being y. Now, the use of this table is to create a bunch of x values and plug them into the equation and get out the y values. Let me use an example. Let's say you had x equal to -2, right? Then all you do to get the y value is everywhere you see an x in the equation, you replace it with -2. So this will get us y equals -2 squared plus -2 minus 6, or 4 minus 2 minus 6, which is just -4. So when x is -2, y is -4. And we can immediately convert these into coordinate pairs, which are in the form xy. This would be -2 comma -4, which is a point on the coordinate plane. Now, you'll see why this is important in just a few moments. Let's take in x equals -1. When you put in x equals -1, you can use the same process again, and you'll get y equals -1 squared plus -1 minus 6. That becomes 1 minus 1 minus 6, or just -6. So this becomes -1, -6. And the point here is -1, comma, -6. That's pretty easy, right? So you can keep doing it. And for 0, you would also get -6. Then for 1, you'd get -4. And finally, for 2, you'd get 0. So it's just repeating the same process for a bunch of more points. Then we immediately convert these into an xy pair so that we can easily graph it as a point. Okay, now let's go ahead and draw our axes. That's the y-axis. Okay, y-axis. And that's the x-axis. All right. So now the first point is -2, comma, -4. Now the first x pair, which is this one right here, it shows how far you need to move in the x direction. Now you need to move 2 in the x direction, but the negative indicates you move 2 to the left. So this 1 and 2, so that's -2. And then -4 means you move 4 in the y direction, or 4 down. That's -1, -2, -3, and that is -4. So your point would be right there. Then -1, comma, -6. You just move 1 to the left, which is over there, and -6, well, we know -4 is right here, so -5 and -6 is right there, and your point is there. Now 0 and -6, you just go down from there, 6, and you'd get there. Once again, I'm just going to remind you that whenever we're graphing a point, we always start from this place. This is the point 0, 0, or you could call it the origin, or just the starting point whenever you're graphing anything. All right, let's keep going. 1, comma, -4. 1 is 1 right in the x direction this time, so that's 1. And -4, we already found where it is. It's right here, so our point is there. And 2, comma, 0 is 2 to the right, so that's 2. And 0, you don't move anywhere in the y direction, so our point will be exactly there on the x-axis. Now what we're going to do is this. Just simply connect the points in a curve as smooth as possible. All right. Now, notice something, that this graph takes the shape of a U, kind of like what I said about a parabola earlier, right? Now, to complete this graph and make it look the best, we can see that it's sort of symmetric. If I were to draw a line like this, we can see that the two sides are sort of mirror images of each other. And that's just a guess right now. So if this 2, comma, 0 point is here, then we think that even this point is here, and this point is -3, comma, 0. Well, how do you prove if this point is on the graph or not? Well, just see this. If you let x equal -3, and if you plug it into the equation, and if you get if you get 0 for y, then it means this point is on the graph. If you get something else, then it isn't. So let's try that. Y equals -3 squared plus -3 minus 6, or 9 minus 3 minus 6, which is 0. And since we got 0 for -3, this point is on the graph. So we can connect these final two dots, and that'll sort of give us the other side of our graph. Now these two arrows, they just mean that the graph is going on forever in that direction. So it just means that if you keep graphing points infinitely, taking all points, of course, that's not possible. We don't have an infinite amount of time to do that. But if you did do that, then you get pretty much the entire graph, which is never ending. So this is just a rough estimate of the graph. And there you go. It's as simple as that to graph a quadratic equation. All right. Thank you for listening. I hope you really enjoyed this video, and I hope you found it really easy to graph a quadratic equation or any equation on a graph. Please subscribe to my channel and watch out for the next video, which will show you the second way to solve a quadratic equation and graph it. And that is for next video. Please subscribe to this channel and leave a huge thumbs up. Thank you for watching.